We want to differentiate 3x plus 1 over x cubed and simplify our answer. The key point here is that we need to recognize that we should be using the quotient rule. So if I say that u is 3x plus 1 and that v is x cubed, then du dx is equal to 3 and dv dx is equal to 3x squared. The quotient rule says that dy dx is v du dx minus u dv dx, all divided by v squared. So here I'm going to get v du dx, so that's going to be x cubed times 3. Take away u dv dx, which is going to be 3x squared, 3x plus 1, all divided by v squared. Now v squared is, of course, x cubed squared, which is x to the power 6. Now we can actually do some cancelling here. We've got a x squared here and here, which would cancel this one down to 4. And so we have 3x, take away 3 lots of 3x plus 1, and that would be over x to the power 4. And now we can tidy that. So that's going to be 3x, take away 9x, take away 3, over x to the 4, which is negative 6x, take away 3 over x to the 4. That's an acceptable answer. You might have written something else, such as put the negative in front and then had 6x plus 3 on x to the 4. Let f dashed x equal x log 2x. Determine a simplified expression for the rate of change of f dashed x. So here, what we want to spot is that the second differential will be the rate of change of the first differential. So once again, we need to differentiate. This time it's going to be the product rule. So once again, we'll take u is x, and we'll take v is ln 2x. So du dx here is going to be 1, and dv dx would be 1 over x. So if you differentiate ln 2x, you get 1 over 2x, and then you multiply by the differential of the inside using the chain rule, and the 2's cancel, and you get 1 over x. So in actual fact, if you differentiate ln kx, where k is a constant, you're always going to get 1 over x because this is going to happen. So f double dashed x is v times du dx, which is log of 2x, plus u times dv dx, and if you do x times 1 over x, you just get 1. Now for part C, we're given that the differential is 4e to the 2x. We're also given some information. This information tells us that when x is equal to 1, g is equal to 0. And we want to go ahead and find g of 5, which means along the way we need to find g of x, and that means that we need to integrate. Now, integrating an exponential is straightforward. So what we have here is 4e to the 2x. We know that exponentials integrate to themselves, and therefore it will go to 4 equal to e to the 2x. But we then have the issue of the chain. And in this case, as we're integrating, it's a reverse chain. So we would divide by the differential of the inside function. So we divide by the 2, because when you differentiate 2x, you get 2. Remember, this kind of reverse chain only works if the differential of the inside is a constant, but it is here, so that's fine. So we get 2e to the 2x plus a constant. The information we were given here is going to allow us to work out that constant. So we know that g of 1 is 0. So when x is 1, g is 0. So 0 equals 2e, and if x is 1, squared plus c, which tells me that c is equal to negative 2e squared. So g of x is 2e to the 2x minus 2e squared. We wanted to calculate g of 5. So that's going to be 2e to the 2 times 5, which is 10, take away 2e squared.